Hey folks, in this episode I'm going to show you how to make this sound reactive audio visualizer in Blender. We're going to be using a combination of geometry nodes and the shader editor to achieve this look here. So without further ado, let's get to it. So open up Blender, we're going to go to Edit, Preferences, and under Add-ons we're going to search for Node and then enable the Node Wrangler here. Once you've enabled that, we're going to click this button, click Save Preferences, and that will ensure the Node Wrangler loads every time we load Blender. We'll then close this window here. I'll navigate to my render tab over here. I'll select EV and I'll enable ray tracing. In the 3D viewport, I'm going to hit N to hide the N panel. I'll hit T to hide the toolbar. I'll then take my cursor to the bottom left until I see a crosshair. I'll left click and drag up and open up a new window. I'll then change this from the 3D viewport to Geometry Nodes Editor. With my default cube selected, I'm going to click New, and that will add a new node tree there. I'll then click N to hide the N panel. I'll navigate over to my Material tab over here. If you haven't got a material on your cube, just click New, and that will add a material. I'll then click this plus button, and that will add a new material slot. I'll then click New to add a new material. For this top material, I'm going to rename this to Tubes, and for the second material, I'm going to rename this to Plane. Maybe for now, I'm going to give this plane a different base colour, so I'm just going to set it to something random, maybe orange. And for the top one, I'm going to change this to blue. I'll just increase my geometry node window. I'm going to take the group input, I'm going to hit delete. I'll then hit Shift A and I'll search for grid, and I'll add a grid there. I'll then connect the mesh socket from the grid node into the geometry socket of the group output. On the grid node, I'm going to change the size of the X and Y to 4 meters. I'll then hit Shift A and I'm going to search for distribute, and I'll select distribute points on faces, and I'll pop that in between there. I'm going to change it from random to poison disk. I'll set the distance minimum to 0.05. I'll set the density max to 500. And as you can see, this has scattered loads of points on the grid. And now I want to instance loads of mesh circles on those points. So I'll hit Shift A and I'll search for instance, and we'll choose instance on points, and I'll pop that in between there. I'll then hit Shift A and I'll search for mesh circle, and I'll pop that down here. I'll then connect the mesh socket from the mesh circle into the instance socket on the instance on points. On the mesh circle node, I'm going to reduce the vertice count to 24 vertices. On the mesh circle node, I'll also change the fill type to N-gon. I want to avoid any problems with the rotation, so I'll just box select these two nodes here. I'm going to hit G, X, and just bring these across over to here. I'll then hit Shift A and I'm going to search for Align, and we'll choose Align Rotation to Vector. I'll just pop that down there for now. I'll then connect the normal socket from the distribute points on faces into the vector socket of the align rotation to vector. I'll then connect the align rotation to vector into the rotation socket of the instance on points. I'll just box select these two nodes. I'm going to hit G, just bring these down to around about there. Maybe bring this one up. I now want to extrude these circles, so I'm going to hit Shift A and I'll search for Extrude, and we'll choose Extrude Mesh, and I'll pop that in there. And now, as you can see, this has extruded all of the circles. Currently, the shading is set to flat, and I want this to be smooth, so I'm going to hit Shift A and I'll search for Set Shade Smooth. I'll select that node, and I'll pop that in the end there. Currently, with this setup, we can manipulate the scale, and we can also manipulate the extrusion amount. I want to manipulate both of these with a combination of a noise texture and the audio data. So let's add the noise texture now. I'm going to hit Shift A and search for Noise, and we'll select Noise Texture. I'll pop that there. I'm going to change it from 3D to 4D. I'm going to set the scale to 1. I'll set the roughness to 0.25. I'll then connect the factor from this noise texture into the scale of the instance on points. I'll just take this noise texture, I'm going to hit G and move it over to here, just to give us a bit of room. And now we just need to remap these values. So I'm going to hit Shift A and I'm going to search for Map, and we'll choose Map Range, and I'll pop that in between there. For the from minimum, I'm going to set this to 0.25. The from maximum, I'm going to set to 1. And the to minimum, I'm going to set to 0.25. We'll then drive this to maximum value using the audio data. I'll then take that same factor from the noise texture and connect it into the offset scale on the extrude mesh. I'll then hit Shift A and I'll search for Map, and we'll choose Map Range, and I'll pop that in between there. I'm not going to change any of the values on this Map Range node. I've just added it into the node tree, so we've got options a bit later on if we decide to manipulate any of these. The main three values we're going to manipulate using the audio data will be this 2 max, this W factor, and also this distortion. Before adding any of the audio data into the mix, I'm just going to complete this node structure quick. So at the end of the node tree, we're going to hit Shift A and we'll search for store, and we'll choose store named attribute, and I'll pop that in between there. I'm going to change this from point to instance. I'll then connect the factor from this noise texture into the value socket of the store named attribute, and we'll give this attribute a name, and I'm going to rename mine to tubes. I'll then hit Shift A and I'll search for set material, and we'll select the set material node and we'll pop that in between there, and in this box we're going to select that material, which will be tubes. I'll then hit Shift A and I'll search for join, and we'll select join geometry and I'll pop that in between there. So currently we've got the tubes, but the floor has disappeared. So we're going to connect the original geometry from this grid node into the top socket of the join geometry node, and that will restore our floor. Maybe I'll hold down Shift, right click and drag through this noodle, and that will create a reroute node. I'll just hit G and bring this over to here. I'm going to do that one more time. So I'm going to hold down Shift, right click and drag. I'm going to hit G and bring this over to here. In fact, I'll just bring this back slightly. I'll then select this set material node. I'm going to hit Shift D to duplicate, and I'll pop that in between there. And for this material, we're going to choose plane. Maybe I can take this reroute node. I'll just hit Control X just to dissolve that, because we can clearly see where this is going. I'll then take this store named attribute node. I'm going to hit Shift D to duplicate, and I'm going to pop that at the end of the node tree over here. I'll then change this from float to color, and I'll change it from instance to face corner. I'll then rename the attribute to base mesh. For this noodle here, where it connects the factor of the noise texture into the value socket of this store named attribute, I'm going to hold down Shift, right click and drag through that noodle, and that will create a reroute node. I'll then hit G. I'll just bring this down to here. I'll then connect this reroute node into the value socket of the other store named attribute node. Maybe I can tidy this up a little. So I'm going to hold down Shift, right click and drag through this noodle here. I'm going to hit G, just bring this down to here. Maybe do it one more time. Hold down Shift, right click and drag, hit G. And that's just so we can see where it's going. Okay, that's almost the node structure complete. We just need to add the audio elements into this now. So I'm just going to decrease the geometry node window. I'll navigate to my outliner, and I'm just going to rename this object to level up. I'll then hide that object from the 3D viewport. I'll then hit Shift A. I'll go empty, and I'll choose single arrow. I'll navigate to the empty data tab over here. I'm going to hit Shift D to duplicate. I'll escape it back in its original position. I'll navigate to the empty data tab over here, and I'll increase the size to 2. I'll then hit Shift D to duplicate. I'll escape it back in its original position, and I'll change the size of this one to 3. In my outliner, I'm going to rename that object to LFAdd. I'll then select the next empty object up in my outliner, and I'm going to rename this to LF multiply for low frequency multiply. I'll then select the last empty object, and I'll rename this to HF multiply for high frequency multiply. I'll navigate to my output tab over here, and I'm going to change my frame rate from 24 FPS to 30 FPS, and I'll also enable render region. The beat I'm using is my own beat, and it's 180 beats per minute. I'll leave a link to this in the description where you can download it for free. So with Blender set to 30 frames per second and my beat is set to 180 BPM, we need to calculate how many frames per beat we get so we can set the end frame on our timeline. That's easy enough. The formula for calculating how many frames per beat we get will be the frames per second times 60 divided by the BPM. So for us, we've got Blender set to 30 frames per second. We need to multiply that by 60 because there's 60 seconds in a minute. We then need to divide that by our BPM, which is 180 BPM, and that will give us 10 frames per beat. So my beat is 4 beats over 4 bars, which gives us 16 beats, and 16 beats multiplied by 10 frames gives us 160 frames. I want the animation to repeat twice, so 160 frames times 2 is 320 frames. So down here, I'm going to set my end frame to 320. In my timeline, I'm going to hit home, and that's to ensure our timeline fits in the window. I'll now change this window from the geometry node editor to the graph editor. I'm going to hit N to hide the N panel. I'm going to select the high frequency multiply object. I'm going to ensure that I skip back to frame 1. I'll then navigate to my object data tab over here, and I'm going to add a keyframe on the Z location transform set to 0. I'll then select the low frequency add empty object. I'll also add a keyframe on the Z location transform set to 0, and I'll do the same for the low frequency multiply object. With the low frequency multiply object selected, I'm going to go to my graph editor. I'm going to click channel, and I'll select sound to samples. Navigate and select the audio track. Mine's called Escape Drum Beats Snippets Clean 180 BPM. Again, I'll leave a link to this in the description where you can download it for free. This menu on the right is where we input the frequency range we want to filter out. And for this empty object, I want to filter out the low frequencies. Here's an audio range frequency chart I prepared. The frequency range I want to filter out will be between 20 Hz and 80 Hz, and that will give us the low end frequencies. So in my lowest frequency range, I'm going to type in 20, and my highest frequency range, I'm going to type in 80. I'll then click Sound to Samples. I'm just going to hold down Control, middle mouse button, and shimmy this about. In the graph editor, you can see that each of these peaks is where a bass kick will trigger the graph. I'll then navigate to my outliner and I'll select the LF add empty object. I'll go back to my graph editor, I'm going to click Channel, and I'll select Sound to Samples. Navigate and select your audio track. Again, this is for low frequency data, and Blender should remember the last values you input into here. If not, just type in 20 and 80. But this time, because this is an add function, I'm going to enable Accumulate. I'll then click Sound to Samples. I'll hold down Control, middle mouse button, and just shimmy my graph around. And because we enabled the Accumulate function, you can see anytime a bass frequency is triggered, it adds to the graph, so it accumulates over time. And this is perfect for driving like a W factor, for example, because it's an endless value. I'll then navigate to the outliner and I'll select the HF multiply empty object. I'll navigate back to my graph editor. I'm going to click Channel and I'll select Sound to Samples. Locate and select your audio track. Now for this one, we want to capture the high frequency data, and the frequency range I want to capture for this will be between 5000 Hz and 20,000 Hz, aka 5 kHz and 20 kHz. For the lowest frequency range, I'm going to type in 5000, and for the highest frequency range, I'm going to type in 20,000. I'll then disable Accumulate because this is a multiply function. I'll then click Sound to Samples. All these peaks should represent the high frequency range, aka all the hi-hats and cymbals. I'll then navigate and click this icon here, and I'm going to change it from the graph editor to the geometry node editor. Now if I was to hit play, we wouldn't hear any audio because these empty objects only contain the data, they don't actually contain the audio. To bring the audio into Blender so we can hear it, I'm going to hit Shift A and I'll go Speaker. I'll then navigate to my audio data tab over here. I'm going to click Open, Locate and select your audio track and click Open Sound Mono. And now if I hit play, you can see that all these empty objects are reacting to the audio. Excellent. I'll just skip back to frame 1. I'll navigate to my outliner and I'm going to unhide the level up object. I'll then select that object. Before we move on, it's a good idea to save your project, so I'm going to go to File, Save As, and I'm going to save my project as Like and Subscribe. Thanks folks, you absolute legends, and then click Save As. We now need to bring that audio data into geometry nodes, so with your level up object selected, I'll navigate into the outliner and I'm going to drag this high frequency multiply object into the geometry node tree. I'll also do the same for the low frequency add object, and I'll also do the same for the low frequency multiply object. I'm going to drag this low frequency add object up to here. I'll then drag the high frequency multiply object over to here, and finally I'll bring the low frequency multiply object down here. So first up, let's animate this W factor on this noise texture. So I'll hit Shift A and I'm going to search for Separate, and we'll choose Separate XYZ, and I'll pop that there. I'll then hit Shift D to duplicate and I pop this down here. Shift D to duplicate one more time and I pop this down here. If you remember, for each of these empty objects, we added a keyframe on the Z location transform. So for each of these empty objects, I'm going to connect the location socket to the vector of the Separate XYZs. And now we have access to these Z components here. Maybe I'll just box select all of these nodes. I'm going to hit G just to give us a bit more room. I'll then connect this Z socket into the W factor of the noise texture, and now if I hit play, you should see that this is reacting to the music. There's not enough movement in this for my liking, so I hit Shift A and I'm going to search for maths, and we'll add a maths node and I'll put that in between there. I'm going to change it from add to multiply, and I'm going to multiply it by 10. I'll then hit play, and as you can see we've got a bit more movement there. Excellent. I want this to be a bit more organic, so I want this W factor to be animated even when the low frequencies aren't triggering the W factor. And to do that, I'm going to add a driver. So I hit Shift A and I'm going to search for value, and we'll choose a constant value, and I'll pop this over here. I'll then connect this into the W factor of the noise texture, and in this value node I'm going to type in hash frame divide by 50. I'll hit enter. I'll just hit play just to see how fast that runs. Okay, I'm happy with that movement. Now we just need to combine this driver with the low frequency data triggers. That's easy enough. So I'm going to take this math node, I'm going to hit Shift D to duplicate, and I'll pop this in between there. I'm going to change it from multiply to add, and I'll then connect this multiply node into the bottom socket of this add node. I'll just hit play. Excellent. I'll just skip back to frame 1. With this value node selected, I'm going to hit F to add a frame, and I'm going to rename this to hash frame divide by 50, and that's just so we know what to input into this value node in case anything goes wrong. Next up, I want to integrate the high frequency audio data. I want to see what this is doing without the interference of these nodes here. So I'm going to hold down Control, right click and drag through this noodle, and that will disconnect that from the loop. I'll then connect this Z value from the separate XYZ into the distortion socket of the noise texture. I'll then hit play to preview the effect. Okay, it's not moving much, so maybe we can take this multiply node here. I'm going to hit Shift D to duplicate, and I'll pop that in between there. I'll then hit play. Okay, that's looking good. If this effect is a bit too much, we can drop the value here if we like. So let's just mix this in with the original low frequency add data. I'll then hit play. Okay, that's looking quite good. Excellent. If you remember, I wanted the audio data to manipulate the maximum scale of these cylinders. And we're going to use this low frequency multiply function here. I only want to view this function, so I need to isolate these from the loop. So I'm going to hold down Shift, right click and drag through this noodle. Hold down Shift, right click and drag through this noodle. I'll just hit G, bring this down to here. I'll box select this one. I'll hit G, bring this down to here. I'll then hold down Control, right click and drag through these two noodles, and that will disconnect them from the loop. I can then take this Z location data from the low frequency multiply function and plug it in the 2 max on the map range node. I'll then hit play, and you can see the effect it's having there. I want this effect to be a bit more predominant, so I'm going to take this math node, I'm going to hit Shift D to duplicate, and I'll pop this down here, and I'll change the value to, let's say, 20. I'll just hit play to preview that. Okay, excellent. I can now reconnect this math node into the distortion socket, and reconnect this math node into the W factor. I'll just skip back to frame 1. I'll now take my cursor to the bottom left until I see a crosshair. I'll left click and drag up and open up a new window. I'm going to keep this window set to geometry nodes, but I'm going to change this one from geometry nodes to the shader editor. I'll then go to my material tab over here. Before we make the two materials, maybe I can set up some lighting quick. So I'm just going to select my point light and my outliner. I'm going to hit delete. I'll then go to my shader editor. I'm going to change it from object to world. I'll then hit Shift A. I'm going to go texture, and we'll choose sky texture, and I'll pop that there. I'm going to connect the color socket from the sky texture node into the color socket of the background node. I'm going to change the sun size to 90 degrees. I'll also increase the sun elevation to 90 degrees. I'm just going to go into rendered view. Maybe I'll take the strength down on my background to 0.9. Maybe it's a good idea to set our camera up as well. So I'm going to select the level up object. I'm going to hit numpad 7, numpad period. I'll then hit Control Alt numpad 0, and that will align the camera to the viewport. I'm going to go to my outliner. I'm going to select my camera. I'm going to set the focal length to, let's say, 24mm. I'll then go to my object data tab over here. I'll then drag the camera down on the Z location until everything is in frame. Maybe I'll set it to 2.5 meters. I'll then navigate to the shader editor. I'm going to change it from world to object. I'll then select the level up object. And for slot 1 with the material tubes, we can now build this material. Maybe I can disable overlays just so we can see what we're doing. I'll hit play. Just skip to a random frame, something that looks kind of good, maybe something around there. So first off, I want to give this a bit of colour based on the attribute that we named tubes. So we're going to call that attribute up in the shader editor. So I'm going to hit Shift A and I'm going to search for attribute, and we'll add an attribute node there. We'll then name this tubes. We're going to change it from geometry to instancer. I'll then hit Shift A and I'm going to search for colour, and we'll choose colour ramp, and I'll pop that there. I'll then click the plus button 3 times. I'll select the first flag. I'm going to click it 1 more time. For this first flag, I'm going to set the colour to green. For this second flag, I'm going to set this to a light blue. I'm going to set this to purple. For this next flag, I'm going to set this to red. And for this flag, I'm going to set this to an orange colour. And finally, for this flag, I'm going to set this to yellow. I'll just drag these flags in. Maybe something around there. We can tweak this in a minute. I'll then change the interpolation type on this colour ramp from linear to ease. I'll then connect the factor from this attribute node into the factor of the colour ramp, and I'll plug the colour from the colour ramp into the base colour of the principal BSDF. I'll just orbit around so we can see what we're doing. I'm going to scrub my timeline using my arrow keys until I can see the floor plane. Okay, I can see the ground through there. So now we know that the lowest points are going to be this end of the color ramp, and the highest points are going to be this end of the color ramp. So now we can adjust the flags on the color ramp to suit the scene. So I'm just going to do that now. Okay, I'll be happy with that. If I was to hit play now, the color palette wouldn't change. The highest points would always be yellow and the lowest points would always be green. I want the colors to change in time with the low frequency audio data, and that's easy enough. I'll hit Shift A and I'm going to search for texture coordinate, and I'll pop that over here. And the coordinate system I want to use will be the low frequency add object. I'll then hit Shift A and I'll search for hue, and we'll choose hue saturation value, and I'll pop that in between there. I'll then take the hue to 0. I'll then hit Shift D to duplicate that node, and I'll pop that in between there, and that should restore it back to its original color. I'll then hit Shift A and I'll search for separate, and we'll choose separate XYZ. And again, we can use the object coordinates from that low frequency add function into the vector of the separate XYZ, and now we've got access to that Z location data. So I'm going to use that Z location data and plug it into the hue on the hue saturation value node, and maybe I'll hit Shift A and we'll search for maths, and we'll add a maths node, and I'll pop that in between there. I'll then change this from add to multiply, and I'll multiply it by 1. And now if I hit play, you should see that the colors are changing. Excellent. I'll just drag this separate XYZ over to here, and maybe I'll drag this texture coordinate over to here. The shading in Eevee is a bit flat when you use a sky texture, so I'm going to add a bit of ambient oculation. So I'll hit Shift A and I'm going to search for mix, and we'll choose mix color, and I'll pop that in between there. I'll then connect the hue saturation value node into the bottom socket of the color mix node. I'll then hit Shift A and I'm going to search for ambient, and we'll choose ambient oculation, and I'll pop this up here. I'm going to connect the ambient oculation socket into the factor of the color mix node, and for socket A, I'm going to turn this to black, and maybe for the distance, I'm going to set this to 0.5. On the principal BSDF, I'm going to set the roughness to 1. I also want some subsurface scattering on these tubes. To do that, I'm going to go to my principal BSDF. I'll expand the subsurface options down here. I'm going to change the weight to 1. Now, you won't see any change in the material, and that's because to use subsurface scattering in Eevee, it requires thickness. So I'll hit Shift A and I'll search for value, and we'll add an input value node. I'll then connect this value node into the thickness socket of the material output, and I'm going to increase the value thickness to 0.2. And in the subsurface scattering section on your principal BSDF, I'm going to set the scale to 0.5. Next up, I want to add some emission on the highest extruded cylinders. So when the cylinders reach their peak, I want them to light up. To do that, I'm going to hit Shift A and I'll search for color, and we'll choose color ramp, and I'll pop that down here. I'll then connect the factor from this attribute node into the factor of the color ramp. On the color ramp, I'm going to click the plus button to add a new flag. I'll then change the color of this flag to black. I'm going to change the interpolation type from linear to B-spline. I'll then select that black flag, and I'll change the position to 0.8. I'll then select the first flag, and I'll change the position to, let's say, 0.7. On my principal BSDF, I'm going to expand the emission options. I'll then connect the color socket from the color ramp into the strength socket of the emission. I'll also connect the color socket from the hue saturation value node into the color socket of the emission. I'll then hit Shift A and I'll search for maths, and I'll add a maths node, and I'll pop that in between there. I'm going to change it from add to multiply, and now this value on the multiply node becomes the strength of the emission. So I'm going to set this value to 250. Now you can see we're getting some emission. Okay, that's the material for the cylinders. Now let's get on with the material for the base plane. That should be a bit easier because we're going to box select all of these nodes here. I'm going to hold down Shift and select this attribute node. I'll then hit Control C to copy. I'll then go to my material tab over here, and I'm going to select the plane material. I'm going to take this principal BSDF. I'm going to hit delete. I'll then hit Control V, and that will paste all those nodes in there. I'll just select my material output. I'm going to hit G and bring this over to here. I'll then connect the principal BSDF into the surface socket of the material output. I'm going to take these two bottom nodes. I'm going to hit delete. I'll also hold down Control, right click and drag through this noodle because we're not going to be using emission. And on your subsurface scattering, I'm going to take the weight all the way down to 0. I'll then collapse the subsurface scattering options. And that's the material done for the base plane. I'll just hit numpad 0 to go into camera view. I'll just hit play just to preview this. Okay, I'm kind of happy with this. Just drag this window down. In fact, I'm going to close my shader editor. So I'm going to take my cursor all the way to the top left of the geometry node window until I see a crosshair. I'll then left click and drag up, and that will collapse that window. You will get better results with this in cycles. So if I go to my render settings over here, and I'll switch my render engine from Eevee to cycles. I'll then enable GPU. I'm going to change my noise threshold to 0.025, and maybe the max samples are set to 256. I'll then enable denoising for my viewport. I'm going to go to lights. I'm going to disable light tree. I'll expand light paths. I'll then disable reflective and refractive caustics. Now obviously this is too bright, so we're going to go to our world tab over here, and for cycles I found a value of 0.1 or 0.2 should be sufficient. If you're not happy with that, by all means adjust the strength on here. The emission isn't really coming through on these cylinders, so I'm going to change this from the geometry node window to the shader editor. I'll then change it from slot 2 to slot 1, which is the tubes material, and then all we have to do is adjust this black flag here until you can see the emission coming through. This will take quite a long time to render in cycles because we've got subsurface scattering and there's a lot going on in the shader editor. So I'm going to go back to my render tab over here. I'm going to change it from cycles back to Eevee. I've got my shadows enabled, I've got ray tracing enabled. Maybe I'll go down to performance and I'll enable high quality normals. I'm going to go back to my world tab over here, and I'm going to increase the strength to 0.9. Hey folks, this is me from the future with a bonus feature. If you open up your geometry node editor, and just after the set shade smooth node, I'm going to hit Shift A, and I'm going to search for subdivision surface, and I'll pop this at the end there. I'll then increase the levels to 2. As you can see, it completely changes the look. And if you want the colours to pop a bit more, we'll change this from geometry nodes to the shader editor, and make sure that you've got your tubes material selected on slot 1. And for this subsurface scattering, I'm going to turn the weight to 0. I'll also collapse these options. I'm just going to go into rendered view quick. I'll then increase the metallic to 1. I'll just select a random frame, and as you can see, it has a completely different look. If you prefer the other look, we'll just open up the geometry node window. So if you don't like this style, we'll just select the subdivision surface, and you can hit M to mute. So you're getting 2 styles for the price of 1. I'll just hit M to unmute that, and I might even turn the levels up on my subdivision surface to 3, and that should smooth it out a bit more. I'll just hit F12 to render out a test frame. That looks quite funky. I'll just hit escape. That's just the bonus feature. Back to the tutorial. I'll then navigate to my output settings over here. I'll go down to output. I'll click this folder icon, select the file location where you want to save your image sequence, and then click accept. You'll then choose the file format. PNG set to RGB at 16-bit should be absolutely fine, but for me, I'm going to set my file format to OpenEXR with a codec of DWAA lossy, and that will decrease my file size whilst increasing dynamic range for post-production. I'll then go to my render tab over here. I'll then scroll down all the way to the bottom and expand color management. I'm going to change my view transform from AGX to ACES 2.0, and I'll increase the gamma to 1.5. I'll then toggle on material preview. I'll hit Ctrl S to save the project. I'll go into solid view, and then it's simply a case of hitting Ctrl F12, and that will render out your image sequence. Join me on Patreon as a free member, and you'll have access to this file alongside other Blender files from previous tutorials. That's the tutorial in a nutshell. I hope you found this useful. If you did, please click like and subscribe. It really helps my channel. Have a great day, level up, and thanks for watching.